Yes, students, today's module is Computation of Arithmetic Mean for Open-Ended Classes. You know that what you mean by open-ended class. Either lower limit of the first class or upper limit of the last class will not be defined. So you have to make certain assumptions because our arithmetic mean computation is based on midpoints. So for an open-ended series, we are making assumption about the classes which are not defined. Either lower limit of the first class or upper limit of the last class. Now, if the first class is not defined, the length of the first class is taken to be equal to length of the immediately succeeding class. Say for example, less than 10 and next class is 10 to 20. That meaning we will assume that the first class is 0 to 10. Similarly, if the last class is not defined, the length of the class is taken to be equal to the length of the immediately preceding class. 70 and above, that is the last class, but the previous class is 50 to 60. That meaning we will assume that the last class is 70 to 80. So like that we have to make assumptions. Now first problem, if you will do, from the following data of income distribution calculate the arithmetic mean. It is given that total income of persons in the highest income group is 435. So the against 80 and above, the total frequency is 435. Then another information, no one is earning less than rupees 20. That meaning the first class is starting with 20 to 30. So the question, below 30, below 40, below 50, below 60, below 70, below 80. And number of persons 16, 36, 61, 76, 87, 95 and 5. So this is an inclusive class. We have to convert it into an exclusive class. So it's given that no one is earning less than 20. So the first class is assumed as 20 to 30. And the given frequency distribution is cumulative frequency distribution. We are converting it into ordinary frequency distribution for computation. Without that, we cannot do that. So when you see the solution, 20 to 30 we have defined, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80 and 80 and above. We are not defining. The total frequency value is known 435. So the mid values 25, 35, 45, 55, 65 and 75. And frequency values are there. So you have to take the FM value, frequency value into mid values. I told you it's very easy to compute the arithmetic mean using step deviation method. Since here in this question, one class is not defined. So we have to go for the direct method. So that is why we are using the direct method. X bar is equal to sigma Fm divided by N. So that is 4800 divided by 100. 100 is the frequency total. So that is rupees 48. Now the problem 2, from the following data find the average wages. This is also a cumulative frequency distribution. Wages in rupees above 0, above 10, above 20, above 30, above 40, above 50, above 60 and above 70. Number of laborers 650, next value is 500, 425, 375, 300, 275, 250 and 100. Cumulative frequency distribution, we have to convert it into ordinary frequency distribution. Now we have to convert that. That meaning 0 to 10. The wages will be 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to 80. So the mid values we will take 5, 15, 25, 35, 45, 55, 65 and 75. Now the mid values. So we are taking deviation as 35. From the mid value 35 we are taking it as the assumed mean. So we are taking deviations from the mid values, minus 30, minus 20, minus 10, 0, 10, 20, 30 and 40. Now D dash we will calculate. That is D values divided by class interval. Class interval is 10 in this case. So that is minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. Now the frequency values we have converted into ordinary frequency values. So first frequency is 150, 75. Next is 50, 75, 25, 25, 150 and 100. So total is 650. Now the values we have got, FD dash values total is 275. Now we are applying the values in the equation. X bar is equal to A plus sigma FD dash by N into I. Substituting the values in the equation, your assumed mean is 35. 35 plus 275 divided by N is the frequency total, 650 into 10. that is 35 plus 4.23, that is equal to rupees 39.23. Always you have to remember that whatever the units, you have to write the units also along with the final answer. Here it is wages, that's why we are writing rupees. Now the last problem for this module, I want to show that how an inclusive class can be converted and compute the arithmetic mean. So from the following distribution of monthly pay of wages, find the mean pay. So monthly pay 200 to 299, 300 to 399, 400 to 499, 500 to 599, 600 to 699, 700 to 799. Number of employees 5, 47, 41, 18, 15 and 4. So if you see the class interval as it is now, it's 99. Once we convert using the correction factor, then our class interval will be 100. That is easy for computation. Because step deviation method, we are using into I. That is into 100 will be easy than into 99. So we are converting. That is how we are converting lower limit of the second class. That is 300 minus upper limit of the first class. So 300 minus 299 divided by 2. 0.5 will be the correction factor. So what we will do, we will subtract 0.5 from all lower limits and we will add correction factor to all upper limits. So the class interval will be 100. So if you see that now it's converted. So 199.5 to 299.5, 299.5 to 399.5, like that up to 699.5 to 799.5. So the mid values also we got 249.5, like that up to 749.5. Now the one mid value we will take it as the assumed mean. So that we are taking 549.5. So we are taking the deviations minus 300, minus 200, minus 100, 0, 100 and 200. Now D dash values we are taking, that is by dividing with the class interval. Class interval is 100 in this case. Minus 0, 3, minus 2, minus 1, 0, 1 and 2. So now frequency values are there and FD dash values you have to take. So frequency total is 130 and FD dash value is 127. Now we have to substitute the values in the equation. So I have explained how we are getting the correction factor. From the lower limit, it's subtracted and it's added to the upper limits. So substituting values in the equation, x bar is equal to a plus sigma fd dash by n into I. So 549.5 was our assumed mean, plus minus 127 divided by 130 into 100. So 549.5 minus 97.69. So the value is rupees 451.81. So here also please remember that we have to use the units when you are writing the final answer. So the valuation will be based on whether you are giving the units also. So that's an important point you have to remember. So this is the module I want to explain. Thank you.